Hey, hello friends. I feel like this is the first day that I'm not immediately starting the stream with kalimba, but don't worry, we will get there. We will also be playing some ukulele so that we can spread the truth about birds. Ooh, actually, that reminds me. I need to put on my bird hat. I guess this kind of plays my hand a little bit, but birds aren't real. Welcome. I'm super psyched to have everybody pulling through for part 3 of the machine learning track, which I hate to bury the lead here, but it turns out that we're halfway through, and this is when we actually start doing stuff that is really machine learning. So it's exciting to get there. Oh my goodness, I love seeing all the comments. Hi, Will. Hello. I am so psyched to have y'all coming back. It is an absolute treat to see you again. And honestly, I am really impressed with the number of people who are sticking with it and are continuing to show up. And I hope that's not just because everybody wants to dye my hair a silly color, but we will do that. Today is actually, we're going to be casting our final votes for what color I dye my hair. So get psyched for that. And probably tonight I will actually dye it. So tomorrow, for our last session, you'll be able to see me with whatever goofy color you pick. It does look like blue and blonde are neck and neck, but they are the two front runners here. But welcome everyone. I will give myself a more formal reintroduction in a second. We will go back with our favorite 3 slides that we have, because they're the only slides we have. But we're going to be getting into some fun stuff. We're going to be looking at logistic regression and segueing right into artificial neural networks. So we're going to cover a lot of ground today. Hello. Hello, Arawa1. You were watching the previous session, missed it yesterday. Well, I'm glad you were able to go back and grab some of it. That is great to hear. I, for anyone wondering, am drinking an iced Americano because we got to stay caffeinated, you know? Drop in the chat if you are drinking anything today, if you have some tea or some juice or some coffee, or ideally some water, you know? Aw, I missed you too, Night782. I am pumped that you're back. Howdy, Aerosol Can. Good to see you, as always. Eating dinner. What are you eating for dinner? Ooh, what is limca? Is that limca? What is limca? Oh, I think I actually have had this before. Let's see. Let's pop into the. So I spent a summer working at a startup in Delhi, and I think I drank a lot of limca. It was like 4 years ago. It was 5 years ago. Wow, time flies. But I don't know if I'm pronouncing it correct, limca. But yeah, it was tasty. Somebody's drinking some water. I love to see that. We got hot water. Yeah, I remember limca being very, very tasty. Well, welcome back, everybody. I guess without further ado, we can get things going. As always, let me know if you have any questions in the chat. Let me know if I am going too fast or too slow. We will, move at whatever pace everybody is doing. But I'm really excited. We're going to do some exciting content today. Hello, Kanisha. It is good to see you again. Hanok tuning in on YouTube. Welcome. So I will just pull up. Where are we? Boom. Okay, so welcome back to Global Hack Week Init 2022. I guess technically this is actually Init for the 2023 season. I noticed that, so apologies that we're getting our years mixed up. But this is the machine learning track. This is in fact part 3, and this time we are deep diving into natural language processing. As I mentioned before, natural language processing is just doing machine learning with natural language, which is just like humans talking, right? So when I'm generating natural language right now, if you're writing in a message in chat, that is natural language. And the reason that we like doing machine learning with natural language so much is because there is so much of it out there, right? The entire internet is natural language. So I guess formally I'll reintroduce myself. My name is Will. If you've been attending the past sessions, you know me, you know who I am. But I'm a software engineer at Google. I'm also a coach at Major League Hacking. I am a Python enthusiast, and it is true that today I am unbelievably caffeinated. You can find me on the internet at W Liffert. And here is our roadmap, and we are now, we're getting really deep in there. So we did our intro to Python on Sunday. Yesterday, we got into natural language basics. We learned about things like tokenization and normalizing our cases, making everything lowercase. And we talked about lemmatization. And we even got our hands on some real world data with those Amazon reviews, which we'll be using more of today. And today we are jumping into really some hard machine learning algorithms. We'll be looking at linear regression. Technically, we'll actually be looking at logistic regression. And we will even get as far as artificial neural networks. So that is going to be a blast. Let's see, I was trying yesterday's code again, but for some reason my accuracy is coming up to 0. That is interesting. We could take a look at that for sure. Somebody's asking, are we going to be doing sentiment analysis? And yes, we're going to be building some powerful sentiment analysis models today. In fact, models that automatically improve themselves. Okay. If you want the flower crown, I'll put on the flower crown. I was wearing my birds aren't real shirt because that'll become relevant later. But no, if you want the flower crown, I live to serve. Flower crown back on. Yes, this is a great question for the GitHub link. Some good housekeeping. So all of the y'all are so good helping me out here. And then so that is the GitHub link. I will post all the code we write today to that GitHub repo, so you can see it as soon as this session is done. And the other thing that I'll throw in the chat is our feedback form. So this is a form, if you have any questions or have any feedback for me, you can send it to me here. I read all of these after every session. Additionally, this is where we will, halfway through the session, we'll be voting for what color I should dye my hair. And this is the last time to vote, right? We're going to get in there and we're going to pick. And tonight, I will dye my hair. I might even hop on Discord and find a Discord channel to sort of do a mini session where I dye my hair, if y'all would enjoy watching me make poor decisions. Ooh, okay, this is fun. I'm looking at the responses as it stands right now, and blue has a strong lead. Blue has 41 votes, and blonde at this point only has 31. And then red is a distant third at 14. But anything could happen. There are 76 people on stream right now, and so if you all voted for blonde, you can make it happen. If you all voted for baby pink, you can make that happen too. I am a humble servant of what the quiz or what the survey says. Okay, I'm just running through some of the comments from yesterday. Let's see. Oh, some great suggestions for more songs to learn in the kalimba. I'll try to learn one for next time. Somebody's asking to see the fish. We could do a break where I try to zoom in on the fish and you can see them. Most folks, things are making sense for them, which is great to hear.
Did you say that again?
Oh my goodness. I really need the little person on my phone listening to me to stop talking. Yeah, so on the whole, it seems like folks are doing pretty well, and like we're getting some good stuff here. Somebody said in all caps, we need math. And we will be getting into some math here. I will confess, this is not going to be the heaviest math ML deep dive ever, but we will be looking at some math and how to use math to improve our model. Let's see. Yes, there is going to be a secret word for today, but I'm not going to tell you the secret word until a little bit later. So you have to stick around, you know? I think without further ado, we can just jump right into it. Oh, somebody asked what the options are. And so what I've been doing is any color that gets more than 2 votes, I've been adding to the survey, but you can always put in sort of like write in your own answer. So right now we have, I didn't add baby pink because that actually did get votes. So I'm going to add baby pink. Boom. Baby pink I just added, and so that should, if you refresh, be an option for you to click because we did get definitely more than 2 votes for that. Good stuff. I think, unless anybody else has any other big questions, I think it is time to get going. Oh, thank you for dropping the check-in. Yes, please go to that check-in link. In fact, I will repost it just so just so everybody has the link on all the platforms. Be sure to check in here. Boom. Yeah, I will confess, I think yesterday I did not actually stream on YouTube. I will be better about that in the future on making sure to add YouTube. I actually forgot that people do tune in on YouTube, which is great. I love that you're tuning in from YouTube. And in the future, I'll make sure all of them are on YouTube. You will still be able to find all the parts on Twitch. I have always done it on Twitch. But yeah, apologies for that. So the other platform that a lot of folks are on is Twitch. That is the one that I post in Discord, and I will post it right now. So we're live here. Can we get a Google T if we do good on the sentiment analysis? LOL. That is a great question. So this year we're not doing a Kaggle competition. Next time I absolutely will bring back the Kaggle competition, and if you submit, you will get a T-shirt and we will send it out. But yeah, no, this time unfortunately no Kaggle competition. Okay, I think we've done a lot or enough preambling, and let's get to it. So I guess just to quickly recap, yesterday, maybe I can even pull up the GitHub really quick. Yesterday, we were looking at sort of the basics of natural language processing. Now, if you go to the GitHub here, you can see part 1 and part 2, and you can scroll through here and see everything that we did. But we brought up this idea of different documents in our corpus, and each document being basically a single piece of text that we can operate on. And we also introduced this idea of sentiment analysis, where we try to figure out if a bit of text is positive or negative, right? And we started with a really simple model where we just said, we're going to pick a couple positive words and we're going to pick a couple negative words. And if you have those positive words in your document, we're going to say you're positive. And if you have more negative words, we're going to see you're negative. And then we also walked through a couple examples where we could improve this by doing things like tokenizing better, so breaking up our document into individual words better. And we introduced this idea of lemmatization, where you can sort of reduce a word to its original sort of simplest form. So instead of running, you become run. And instead of loving, you become love. And instead of better, you become good, and things like that. And then kind of finally, here, I'll make this bigger because I'm sure you can't really see it at that point. Yeah, it's probably, maybe that's good. Let me know if the font size is too big or too small. But then we finally introduced some real data from Amazon reviews where we have like some text from the review, and we also had a score, like a 0 to 5 star score, right? And that was basically our recap of yesterday. Somebody said MLH also do Kaggle competitions. Yes, I do Kaggle competitions sometimes. I did one the last Global Hack Week that I participated in, and we were predicting housing prices, and we were building a model that way. And everybody who participated got a T-shirt. And so I think next time I'm going to do another Kaggle competition. This time we're kind of just playing around and learning a lot about natural language processing. But next time we can kind of get a little bit more serious and have kind of a task that we'll be predicting on. Somebody asked, what is Kaggle? Kaggle is actually really cool. It is a platform. It's a great place to learn about machine learning, but it is basically a hub for data sets and for competitions where you can build a model and actually pit your model against other people's models and see which AI is the smartest, basically. So it's a really fun platform to learn and compete on. Okay, so we kind of did our quick recap of yesterday. Now today, I guess we'll reach the end where we said we could improve our model by adding more words, right? We had our list of good words and bad words, and we said, well, we can just pick additional words to put in our model, right? And so we changed our model and we said, okay, let's say our bad words include bad, poor, terrible, hate, disappointed, and our good words contain good, great, wonderful, love, impressed. And by adding those extra words, we actually did get better performance, right? Originally, our accuracy was 22%. So 22% of the predictions we made were right. And by adding additional words, we got all the way up to 33%, right? We got a whole third of them right. But we talked about how this is kind of tedious and we might pick the wrong words, right? We also talked about cases where two words work together in kind of a weird way, right? Somebody said, hey, if you say this is bad, that means one thing. But if you say this is not bad, that means something totally different, even though the word bad is still there. And so there were a lot of limitations to our original model. And that's what we're going to be looking at today and seeing if we can improve that. So to kick off, we can go back to Google Colab. I will drop the link for Colab, and reminders, this is just a way to run little bits of code. So I'll click a new notebook, and that will let us experiment and play around here. Somebody said, can you post the GitHub link on YouTube or just here? Yes, I will repost the GitHub link. Here's the GitHub link, and this has the previous code, and it has code. At the end of this session, I'll post the code that we wrote today. But I'll be doing it live here. Okay. So, and actually for starters, I want us to copy over a little bit of code from yesterday. So if you open that up, we can just grab our code for importing our data, right? So we can import our data this way. It'll take a second to download. And remember, this is a bunch of Amazon reviews. Give us some output. And we can grab this little snippet here. We can say our data frame is equal to pd.readcsv, and we'll pass in, I guess we can just grab our output and read that CSV that we just downloaded. So this chunk of code, it just downloads to our local environment the data, and then here we're actually reading it into Python. And then we'll say df equals, this is a funky little bit of code where we're saying we'll only look at reviews where the stars are 1 through 5. So technically in our original data set, some of our reviews had 0 stars just as a null value, but we're only going to look at scores that are greater than 0. So score can be 1, 2, 3, 4, or 5. And then finally, we're just going to grab the first 1,000 records, just because that will allow us to sort of experiment a little bit faster. In fact, we'll call this raw df, and we'll call this raw df as well, and then df will be equal to the first 1,000 lines of raw df. And if you are interested, if you ever want me to paste code into the comments for you to grab, I'm always happy to do that. Oh, somebody asked, can I talk about GDown? Yeah, absolutely. So GDown is a really nice library that just allows you to download things from Google Drive easily. Google Drive is a little bit funny. If you go to just this exact URL, you'll get not just the actual file, but you'll get this little screen. And so what GDown does is it just uses that link, but then it will automatically download it for you. So it's just a utility that allows you to download things from Google Drive a little bit more easily. Because I downloaded this data originally and then hosted it on Google Drive. Somebody asked, can you mount the drive? You absolutely can mount the drive. What gets a little bit tricky about that, if I recall, is if you mount your Google Drive directly, you need to authenticate. And like even if it is a public thing that you're downloading. And so it's on my Google Drive. And so you would then have to authenticate to my Google Drive in order to mount it. And I think that is just more of a hassle than it's worth. I might be wrong about that. If anybody's very familiar, you can say, okay, yeah, with the drive.mount function after auth. And if we can avoid doing auth stuff, yeah, I'll avoid that. Okay, cool. So at this point, if we run this second bit of code, we'll read in all of our review data. And we can just throw in a df.head, which just shows us the first few rows of our data set. And this should look familiar. This is the same data set we were playing with yesterday, right? We have product information, we have some user information. We talked about the helpfulness scores, which are kind of unimportant for us, but they're just a sign of did other users find this review helpful? And then the really important things are we have this score, which is the number of stars the user gave it, right? Did they give it 1 star or 2 stars or 3 stars or 4 stars or 5 stars? And then we have 2 other interesting bits of information. We have the summary and we have the full text of the review. And so our big task here is to see, can we take this text and can we predict how many stars the user was about to give this product? And we talked about this a little bit yesterday, is why is this useful? And there are a lot of reasons sentiment analysis is useful for companies. But like one example you can throw out is, say you are helping the marketing department at a company you work for, and you want to know, are people on Twitter, are they being positive about your company or are they being negative? And so if you could train this model to take some text and predict how many stars a user would give your product, well, then you could just go to Twitter get all of the tweets that mention you, and then do sentiment analysis and just put your ear to the ground and see, is everybody generally pretty happy with our product, or are we having issues, right? That's just one example of where you might use sentiment analysis, because it can be a really powerful tool. Cool. Now we're just going to whole cloth. We're just going to copy some code from yesterday because we're going to use it again. Technically, you could actually do this all in the same notebook if you want to, but I'm just going to be copying, and I'll paste all the code that I copy from our last script. So this is just all the code that gives us our pre-process script. I'll drop that in there. Unfortunately, if I recall, the comments, it'll destroy a lot of the indentation, so you'll have to go back in and indent. I'm sure there's got to be a better way to do that. I guess I could drop it on, if we're all on Discord, I could drop it in Discord. Maybe that's a better option. But there is our pre-process script. Cool stuff. Somebody asked, does this tie into data science as well? Yeah, absolutely. We will be looking at a little bit of sort of data science-y concepts, and tomorrow we're going to dive really deep into sort of tools of the trade around machine learning and data science. We're going to look more deeply at things like overfitting and how to avoid that, and a lot of neat concepts like that. We'll also be looking at things today like cross-validation and using a holdout test set. So these are all concepts that are really relevant in data science for sure. Good stuff. So we just copied our pre-process script. And now we are going to take a step back and think about that model we built yesterday, right? Somebody, oh yeah, Pastebin would work. Send it through Blahaj. He never messes his code indentation up. True. Blahaj is really good at keeping his indentation. Yeah, no, Pastebin would also be a good option. Somebody asked, can you just share the collab? That's actually a good question. Can you share copy-only access? Because that would actually be very powerful. Let's see, general access. What if we said anyone with this? Okay, anyone with the link is a viewer. Honestly, let's do it. I actually love that as a recommendation. I love collab. I'm learning new things about it every day. So, boom, you can all hop in there and see what I'm doing. Yeah, okay. I think viewer is the right. Yeah, I don't want to give y'all comment access. That'd be a mess. You know, if you want to comment on Twitch or on YouTube. Yeah. Okay. This is great. We're innovating here, y'all. And I'm sure in a second I'll see people popping up and viewing. Fun stuff. So yeah, you can just go there to copy code that I write, and that is very powerful. Okay, so yesterday we built this model where we were just looking for individual words, right? And we were basically saying we're giving some words a weight of +1, and we're giving other words a weight of -1, right? And I'm throwing out this word weight because it's used a lot, where you say this thing gets a kind of associated value. It gets a weight of +1 if we think it's positive, and it gets a weight of -1 if we think it's negative. And if we add all those together, we get some total value that's either positive or negative, right? And at the end, we got a lot of really great and insightful comments that said, hey, if you just found a really good list of positive or negative words and you already had their weights, you could just use those and your model would be a lot better. And I think this is a great comment, but there are a couple catches here, right? One of them is that every task is a little bit different, right? Words in different contexts have slightly different meanings. I threw out kind of this silly example of if 20 or 30 years ago you called somebody a baddie, that would mean that they are bad. But today, if you said, oh, that woman, she's a real baddie, that is actually in some sort of linguistic communities, that is a sign of saying like, oh, that person is very cool, right? Or that person is like a person I want to be with. And that's like a silly example, but it is a case where the context is really important. And so if we just got one general sort of bucket of good or bad words, they might not always line up. And so the thing that we're going to do today is try to learn stuff from our data. We're actually going to go and we're going to count which words happen to appear in 5-star reviews a lot and don't appear in other reviews a lot. And then we'll also count what words tend to appear in 1-star reviews a lot and don't appear in other reviews. And I'm just going to reiterate that to get the point across. We want to see what words are the most common in 5-star reviews, because those words are probably positive. Let's see, somebody asked, would the solution be something akin to passing a source file, make an array of tokens, and specify if it is a modifier, like not is a token and is a modifier of the next token? Oh, so this is interesting. And this is, yesterday we were talking about rules-based models, and this is actually like a really, really great idea for a rules-based model. You could imagine going back and basically saying, yeah, check to see if you have the word not, and if you do have the word not, multiply the next word by -1 or something. We're going to be looking at other ways of solving that kind of problem. But no, I think that is a good idea. We're not going to be diving too deep into it here, but I think that would be a cool thing to play around with and try to build sort of not as a modifier of -1 or multiplying by -1 and switching the sign. But yeah, I think that's an awesome comment. Okay, so for starters, so we're on the warpath to try to identify from our data set good words and bad words, right? For starters, I want us to import the default dict object. And if you remember from yesterday, this is just a dictionary where we can give it a default value, right? So we'll say collections import default dict. And what this allows us to do is we can count things, but we can start at 0. So normally, if you are counting things in a dictionary, you have to always check, is this a new key for the dictionary? And if it is, set it to 0. And if it's not a new key, use the value that's in there. But we can use a default dict to say, always start counting at 0 when it's something new. And it's actually the collections dictionary, or the collections library will import default dict. So we're now going to make 3 different dictionaries. We're going to make a dictionary of 5-star counts. And we'll say that as a default dict, where the default is an integer, and that will default to 0. So in this dictionary, we're just going to store the word will be the key, and then the count, the value, will be the number of times that word appears in a 5-star review. And the idea is if it appears in a 5-star review a lot, it's very likely to be a positive word or a word with positive sentiment. And let's see, somebody said, I feel like the idea I mentioned earlier would be difficult to scale since natural language doesn't strictly have a 100% followed grammar. It might be tough. Yeah, no, I think this is definitely a reason that, I think exactly what you identified is one of the reasons that rules-based models are tricky, right? Because language is really good at breaking rules. And yeah, you could say, oh yeah, it modifies the next word. But like, what if I said, oh, it's not that bad? And so suddenly not is modifying that, but that isn't really positive or negative, right? But bad is negative. And so it's, you can identify all these little pathological cases. Here's a fun word. If you haven't heard this word before, if somebody says a pathological case, it is like a test case that somebody comes up with that like breaks your system. So, the system of, oh, not just multiplies the next word by -1. That's sort of like a decent model, but I come up with the pathological case of, well, what about not that bad? And it's a sort of a specific test case that breaks the model. Okay, so getting back to our code, we have a dictionary called 5-star counts that just will tell us how many times a word appears in a 5-star review. Okay, Luna Lu, this is actually a good comment that we will get to in a second. But yeah, you're jumping ahead. Okay, so let's do a loop and loop through all of our reviews. So we'll say for text comma score in, and we're going to use something called the zip function, where we'll say zip, and we'll have df text and df score. Zip is a really, really nice function that just allows you to iterate through 2 different lists at the same time. So remember, text is a series that we can iterate through, and score is another series that we can iterate through. And by zipping them, this just allows us to iterate through both of them at the same time. So we can hit return here, and now that we have the actual text, we can say for token in, and we actually have to define our tokens. So we'll say tokens equals preprocess. We'll use our preprocess script. So preprocess with lemmatization, and we'll pass in our text. So then we can say for token in tokens. So we're just going through our entire data set and looking at every single word. And now we can use the score to tell if we're in a 5-star review or not. So we can say if score is equal to 5. And we can say 5-star counts, and we'll use the token as our key, and we'll add 1 to it. And this is where the default dict thing becomes important, because if we've never seen this word before, it'll just default to 0, right? And so now we should be able to run this through and get all of the counts of words that appear in 5-star reviews. And this might take actually a second to run, because we have 1,000 different records and we're running on all of them. Let's see. Somebody said, I guess the word that appears most will be the. We'll probably remove stop words. This is a good option. Removing stop words is one option, but there actually is. Well, we'll get to it. I'm getting ahead of myself, but there is a fun other way you can deal with words like the. Okay, so now what we want to do is we want to see what are our most common words, right? Like what words have the highest counts. And so we can say 5-star %. Oh, wait, no. What we can say is, let's just sort our dictionary. So we'll use the sorted function. And we will say 5-star counts. And we will want to sort our keys. So we can use the keys function. But we want to use as a key the actual value, right? So we'll say our key is equal to, and we'll use the lambda keyword here to make a little lambda function. So for any given token, we'll say the thing that you should sort by is the counts that it has. So we'll say 5-star counts and type in token. Now, this is a little bit of there's a lot going on here, right? So we want to sort all of our tokens, but we want to sort them not alphabetically, which is the default way we'd sort them, but we want to sort them by how much their count is in our dictionary. And that's what this parameter here does. It says use as the key for sorting, use the actual value stored in 5-star counts. So let that sink in for a second. Let me know if you have any questions. But now what we can do is we can say, let's just take the top 5 words. And actually, this would normally count from 0. It would sort from 0 up. And so we'll actually also pass in the reverse keyword. Reverse equals true. Y'all, this is so much easier now that I'm not copying and pasting code into the chat. Whoever suggested this is an absolute genius. And let's make this bigger again. Great. Okay, incredible. So we have just realized that, and other people kind of saw this coming, that the most common words in our 5-star reviews are just the most common words ever, right? So remember, our tokenization will make periods and commas their own tokens. And so our most common tokens are period, the word the word be, a comma, and the word I. And so we need some way to get around this fact that some words are just common everywhere. And this is where we're going to use an idea. It is technically an idea called TF-IDF, which is really one of my favorite things in natural language processing. So TF-IDF stands for term frequency inverse document frequency. And we're going to unpack that here. This basically just means count how many times the word appears in the documents you care about, but then divide it by the number of times the word appears anywhere, right? So I'm going to repeat that. Count the number of times the word appears in the documents you care about, and then divide it by the number of times it appears anywhere. And there's a little bit of nuance here, but basically this just means you're going to penalize words that are just common everywhere. And so you will try to hone in on the words that are really important for the documents you're looking at. So the way that we can do this is we can just create another dictionary, and we'll call it total counts. And we'll make this another default dict. And inside here, after adding if it's equal to 5, we can say total counts token. We'll just always add 1 to it. So no matter where it appears, if it's in a 5-star review or any review, we'll add it to our total counts. And so now if we rerun this, we can now do a sort of normalized a normalized frequency using that the total document frequency there. So we'll say we'll call this maybe 5-star percent, or we'll call this 5-star normalized. And here we can use something called a dictionary comprehension. If you remember at the beginning of the week, the intro to Python, we talked about list comprehensions, where you can sort of shove a whole for loop inside a single line inside of a two square brackets. You can also do this with dictionaries. So what we'll do is we'll do an equal sign, and we'll do an opening curly brace, and we'll say token colon, and we'll say that we'll take our 5-star counts of the token, and we'll just divide by our total counts of that same token. So we'll say how many times does it appear in a 5-star review divided by how many times does it appear anywhere. So somebody said, can you repeat what we all have to do for the TF-IDF and also why? Somebody's saying that do they use log ID in IDF, right? Yeah, so there's a lot of nuance to TF-IDF, and technically I'm not even doing inverse document frequency. I'm just doing inverse frequency. So know that this is a little bit of a simplified version of TF-IDF, but it'll get the job done for us. So somebody asked, can you repeat what we have to do for TF-IDF? And really all we're saying is we're going to take the number of times the word appears in 5-star reviews, and we're going to divide it by the number of times it appears anywhere. And so what this means is that really, really common words, well, they'll be really common in 5-star reviews, but they'll also be really common in 4-star reviews and 3-star reviews and 2-star reviews. And so we'll divide that by a really big number. On the other hand, a word like great or incredible, it'll probably be really common in 5-star reviews, but it won't be as common other places. And so you'll divide that top number by a smaller number, and you'll end up with a bigger value for your, like how common is it in 5-star reviews. And maybe actually, I'm trying to think of like the sort of easiest way to explain this. But maybe we actually just look at the example here. And actually, I won't use a dictionary comprehension because it's a little bit more complicated than it needs to be. Okay, so we'll say 5-star normalized is a dictionary. And we will just say for token in in total counts. I would say in 5-star counts. So we'll go through every token that we've logged, and we will just say we'll take 5-star counts of the token. So remember, this is how many times that word appears in a 5-star review. And we'll just divide it by how many times that word appears in any review. So for example, the word the, it appears a lot in 5-star reviews, but it also appears a lot in all the reviews. And so we'll end up dividing that by a big number. And so this will be we'll call it our normalized 5-star count. And so then we can just say 5-star normalized, we'll store for that token, we'll store our normalized value. And so now we should be able to run this, and we can even just copy this sorting function again. And we'll assign this to a list called good tokens. And instead of 5-star counts, we'll run it on 5-star normalized. And then we can print our good tokens. And hopefully, now that we have normalized and we've used TF-IDF, we should get better options. Okay, so this is actually really good. So now what do we see? What are we seeing as our results? Well, we see the word vitality, we see the word stew, we see the word process, Labrador, and finicky. Now, do you notice anything about these words? Like if I just said these words to you, would you have any sense of like what's special about these words? Because I actually wouldn't say these words are really all that positive, right? I mean, vitality is maybe a positive word, but really I would say all these words are just really uncommon. They're not super common words, right? And if you think about it, this kind of makes sense, because if a word only appears once, then that denominator is only going to be 1, and your numerator is going to be this big number, right? And so this is where we can use an additional idea of something called a prior, which is basically just say, assume you've seen all the words at least a couple times. And this is actually a place where our default dict can be useful. So remember, we said our default dict of total counts will always default to 1. But if we want to, we can default it to something else, right? We can say lambda colon, and we could say 2. And so this just says like, hey, assume you've seen all the words at least twice, right? And so this means we're not going to prioritize really rare words. And so we'll say, actually, you have to appear at least a couple times in order to be considered a sort of good word that's important. This idea of a prior makes sense to everybody. I know this is another kind of a complex idea. But the idea is we're not going to give you special treatment just because you're a super rare word. So now we should be able to run this again. And okay, cool. We're getting better. We're getting better. You can see now we have words like thank, highly, and flavor. And I would say that we're getting closer to at least what I would say seems like actually really positive words. It's still a little bit tricky, like tortilla is still there. And something we can do is we can actually just play with our prior values. So we said, what if we just said we've seen all the words twice? Well, what if we said we've seen all the words 10 times? How does that change things? Let's run that and see what that gives us. And actually, let's grab the top 10 words just to get a slightly better sense. Okay, awesome. So we've now done some tweaking, and this list actually I'm pretty happy with. This dash dash is a little bit tricky, and that might be something we just want to get rid of. But if we look at all the other words, ever is interesting, but like great, highly, delicious. I actually love this, exclamation points. It totally makes sense that exclamation points are actually more likely to be in a positive review, right? I use exclamation points way more when I'm excited about something than if I'm like upset or angry. Perfect, love, Amazon, best. So we have now, from our data, learned some words that tend to be correlated with positive reviews. Does that all? I want to check it. Does that all make sense? Does that sort of does that parse for everybody? I'll say maybe drop me in the chat. Give me a 1 if you are completely lost. Give me a 2 if this kind of makes sense and you're still trying to get a hold of it. And then give me a 3 if you're like, yeah, Will, this is all totally easy and you're being boring. Yeah, somebody asked if I can explain it one more time, and absolutely. Okay, awesome. We're getting a lot of 2s, we're getting some 3s. That's actually a great place to be. If you are understanding some of it, then we can run through it one more time. Okay, so we started by just saying we're going to count the number of times that words appear in 5-star reviews, right? And that was going to be kind of a signal of, well, hey, if words appear in 5-star reviews a lot, then that means they're probably positive words, right? Because we're trying to identify positive words in our text. But then we looked at that and we looked at the words that appear the most, and they're all kind of boring words, right? They're all words that are like just common everywhere, right? And so it's like, okay, the words that are most common in 5-star reviews are also the words that are most common in 4-star reviews and 3-star reviews, right? Like just the word the appears everywhere. And so we need some way of filtering out those words that are just common everywhere. So we added this idea of, well, let's just count how much they appear everywhere and divide by that. So it's like you get points if you appear a lot in 5-star reviews, but you lose points if you're common everywhere. So we'll get the words that are basically only common in 5-star reviews is kind of the idea we set up. And then we hit one more little bump, is that we started finding words that were just not that common at all, right? It was kind of the opposite problem, because it's like, okay, the word, I think we saw the word tortilla, and it's like, well, maybe only one of the reviews that just happened to be 5 stars was about tortillas, and there was no other reviews about tortillas. And we could solve that by getting a lot more data, but another thing that we can kind of cheat our way through is we can just say, let's start all our total counts at 10. So let's say we saw a lot of data beforehand. We'll just pretend and say that we saw every word at least 10 times. And this somebody was asking for math. We're kind of getting into the math here, is that if you increase your denominator, you are going to filter out things that are just uncommon everywhere. And so you basically need to have at least a couple occurrences in order to be considered a sort of important word for our 5-star reviews. Now, this is kind of a deep concept, and we're really getting into some math here. So if you need a second to think about it more, if you want to ask another question, we can totally do that. But after we do those 3 adjustments, we count how often the words appear in 5-star reviews, we divide by how much they appear everywhere, and we make this assumption that let's just pretend we've seen all the words at least 10 times before. Then we can get this list of words that actually make some sense, right? Now, some of these words are a little bit tricky, like the word ever, I don't know, maybe. The word Amazon, that seems a little bit confusing. And this dash dash, like, I don't know, I guess that is just a thing that happens to appear. But all the rest of the words, great, highly, delicious, perfect, love, best, these are actually really, really good positive words, right? And they're positive words we know appear in Amazon reviews. So what we have just done is figured out a list of words that we say have a positive weight, right? That if you know one of these words is in your sentence, then you know that the probability that sentence is positive is a little bit higher, right? And the important thing is we didn't have to come up with any of that ourselves. Our data just told us that. We learned it purely from the data we had access to. And this is, if you've ever heard this thing that people say that, oh, you need a lot of data in order to make your model good, this is what they're talking about, right? The more data you have, the better your list of weights here will be. And the more you'll know, oh yeah, this is a really, really good word to use for positive sentiment. Let's see, somebody said, can we remove unwanted words from the data like dash dash and work only with filtered words? Yeah, so this is a great question. And the short answer is yes, that's totally something that you can do. I think it kind of gets back to this idea that that's some manual work you're doing. And if you can manage it, it is always nice to just have things come from your data. And something that I would say is that, hey, I'm not really sure why that dash dash is in there, but it is true that that dash dash is more common in 5-star reviews than it is in the other reviews, right? We kind of know that. And so I might actually not be able to tell you exactly why that's correlated with positive sentiment, but our data tells us that it is. And it's good to ask this question of like, well, hey, doesn't that seem wrong? But sometimes your model figures out things that you can't, right? And so sometimes you actually just want to trust your model that it has figured out something, and that maybe you don't fully understand it. So I think if you wanted to filter out words that don't make sense, like dash dash, totally fair. If you wanted to just get rid of all punctuation, that would also be fair. But there's also maybe some sense in saying, maybe it has learned something that we don't totally know. Let's see, somebody said, sometimes people mistype, so can sentiment analysis differentiate those comments or just ignore it? This is a great question. And this is one of the big ideas in machine learning, is that, and this is a thing that they have proven time and time again, that your data doesn't have to be perfect. Like, would it be great if all of our reviews were perfectly spell checked? That would be great, right? But what we know is if you get enough data, even if all of it is kind of messy, that if you get enough of it, your model can learn the things that are common between all of your examples. And this is like kind of a deep concept that you can prove with a lot of interesting math. But kind of the idea is everybody can be a little bit wrong, but if they're all wrong in different ways, then you can figure out what the truth is by kind of averaging everything together. And that's what we talk about more. But the answer is, part of the beauty of big data is that we actually don't have to worry about misspellings. And like you said, our model will just learn to ignore them. Okay, cool. So we've gotten a list of words that we feel pretty confident are positive, at least a lot of them. But now we can do the same thing and try to find a list of words that is negative, right? And we can do this, it's pretty much the same process. We can say 1-star counts. And we'll say that's also a default dict that defaults to 0. And in here, we'll have another branch that says elif score equals 1. And then we'll say 1-star counts for that token. it's incremented by 1. So this is nothing new. We're just saying count the number of times a word appears in 1-star reviews. And maybe it's kind of interesting to do this, but we could also just check, does it appear, like what are just the normal, just by raw counts, what appears in there a lot. Oh, we didn't actually write this. Let's run it again. Not to beat a dead horse here, but this is kind of the joy of a notebook, is that I can go back and edit this piece of code and just run it again really easily. That's kind of the beauty part. And oh, this is perfect. This is great, right? So you can see we get the almost, I think it actually is literally the exact same 5 words, because they're just the 5 words that people use the most just in general, right? And so that's a kind of a further illustration of why just looking at raw counts can be misleading. So now we can normalize again, and we can say for token in 1-star counts. We can say normalized 1-star count. We'll say 1-star counts token divided by total counts. And normalized 1-star count, 1-star normalized. I actually have to initialize 1-star normalized up here. So if all goes according to plan, we should be able to also get a list of bad tokens. And, oh wait, no, bad star. Oh, it's been a long day. 1-star normalized. 1-star normalized. And let's just also print out bad tokens at the end here. Okay, incredible. We get a second list here, and we see frosting. Actually, frosting is interesting. That's maybe one that I'm curious. But horrible. Return. This is a great case where, in general, the word return is not like a negative thing. But if you are reading an Amazon review and somebody talks about returning something, that is a negative, that should have negative sentiment, right? So that's like a very specific thing that we learned here. The other words make sense. Stale, throw, I assume is from like throw away, like I had to throw it away. Sour, rancid also makes sense. Let's see. Oh yeah, somebody asking if Python can recognize emojis. Yes, actually, you can totally do some interesting machine learning, like natural language processing with emojis. Yeah, Python can support Unicode characters, and this is if I had like 7 days, I would do like a whole day just on character encodings because they're really, really interesting. But yes, you can actually interact pretty easily with emojis in Python. There are a few things that you have to be careful about, but for the most part, it is not that bad. Okay, so we have gotten a list of sort of good tokens and bad tokens. And now we can really use our predict function from yesterday, but we have just improved it with this new set of tokens that we have learned are good and bad, right? So I'm just going to copy whole cloth again our predict function from yesterday. TF-IDF, great thing. Actually, just to recap, TF-IDF, that's when we normalized based on how common the word was everywhere. Boom. Okay, so this is our predict stars from function from yesterday. Reminder, if you want to copy this, you can just jump into the document that I'm working with live right now. Kenisha asked, we'll be using the same normalized count for both good and bad tokens. Yes, yeah. So if we scroll back up, we can see here we're normalizing the 5-star normalized, or we're normalizing 5-star counts by dividing the number of times it appeared in a 5-star review divided by total counts. And here we're dividing the number of times it appeared in 1-star reviews divided by total counts. So yeah, we're normalizing in just the same way. We're just saying we only want the words that basically only appear in good or in positive reviews. And then separately, we only want the words that only appear a lot in negative reviews. Yeah, great question. And so we have our good and bad tokens, and we have our predict function here. And we can do the same thing where we wrap it in a lambda and pass some parameters. So we can say, oh yeah, someone's asking if I can drop the collab link again, and I will do that. Copy link. Boom. In fact, you know what? We can actually make this function simpler. It'll just accept the document, and we will just say in here, we'll just edit the function itself. And we will say preprocess with lemmatization. That's just the same preprocess function that we built yesterday. And then we will just use our good tokens and bad tokens that we defined up here inside our function. So we can run this, and we can use our, remember we have our data frame. Here we'll say data frame.head. So we have a column called text, and we have a column called score. And the way that we can generate predictions is we can say df prediction is equal to, and we'll use that text column, then we'll apply our prediction column to every single row of text. So we'll say apply predict stars. And so now we're running through and predicting on every single row. Yeah, Fleabag, I was just dropping the link again because somebody else had missed it. Yeah, I know it, but you can update it live. But yeah, people join wherever they join, and I don't want to make people scroll back up in the comments, you know. Good stuff. Okay, so we ran our predictions. It took a second, but now we can just run df head again. We should be able to see our predictions live. Yeah, there we go. We have some predictions. And okay, this is super interesting. Remember, we're still using our sort of basic level of if your sentiment is positive, we add 1. If your sentiment is negative, we subtract 1. And then we just do this very basic comparison of if your sentiment is greater than 1, we'll say that you're 5 stars. If your sentiment is equal to 1, we'll say you're 4 stars. If your sentiment is 0, we'll say you're equal to 3 stars, and so on and so forth. And we can look at our predictions. And we've gotten some of them right and some of them wrong, right? So we see, okay, score for this one is 5, and we gave it a 5. But our first one was 5, and we gave it a 3. But this one in the middle, it got a 4, and we gave it a 4. So we're getting some of them right, we're getting some of them wrong. But just like last time, we don't want to have to look through all of these individual cases. And so we can do something called computing the accuracy. And this is just where we count up the number of correct cases. So we'll say correct cases is equal to, and it's equal to the sum of all the times that our prediction is equal to the actual score. So this will just add 1 to correct cases anytime we got something right. And then we'll say total cases, and that's just equal to the length of how many predictions did we make. And then we can just print out correct cases divided by total cases. The prediction is a really simple idea. It's just like we talked about. If you have a quiz and there are 10 questions and you get 5 of them right, then you made a 50%, right? Your accuracy is 50%. So you run this, and boom, 46.1. Now, if you remember, let me see if I can pull back up our lab from yesterday. If I recall, we were getting 33% or close to it yesterday. And just by looking at the data itself again, we have improved up to 46%. Okay, yeah, thank you for dropping the old stats. It was 22%, and then we got it up to 33%. And now, just by looking at our data, DF stands for data frame. So that is our, this guy right here. It's kind of like a way of storing data kind of in like an Excel spreadsheet. Now, so we've gotten up to 46% accuracy. And this is really cool. One of the things we threw out yesterday was you want to know what would your accuracy be if you randomly guessed. And because in our case, there are 5 different classes that we're picking from, 1 in 5, you would picture you'd get 1 in 5 on right if you were just guessing, and that would be 20%. So we're now doing much better than 20% of random guessing. We're up to 46%, and that is nothing to be ashamed of, right? It still is technically less than half of the right cases, but this is a harder prediction problem. Yeah, we got some great answers. I love it when I see y'all answering each other's questions. It's like, it makes me so happy because it's like we're building a community, It feels good. Let's see. Do you have a data frame? Yeah, get psyched. It is always really fun to make an adjustment to your model and to see it improve. Now, this is where there are a million different directions we could take it, but we're also at about halftime, and so I think it's time to finish voting on what color my hair is going to be. Take a break, get a drink of water, and I will play you my song about birds. Okay, so reminder that we're collecting votes on what color I should dye my hair. And, let's drop that link again. And you have to include a secret word in your vote for it to count. So today we're going to say the secret word. What should the secret word be today? Here's the form you need to fill out. Okay. I know this is a bad word because it's hard to spell, but the secret word is going to be accuracy. I like accuracy. The secret word would be accuracy, and I will drop that in. So if you put in accuracy into the comment section when you submit your vote, that will be the word you need to include to make it count. So I'll just look at right now. If we look at just the right ones, oh wow, blonde is making a comeback. Okay, so red got 4 more votes. It used to be 10, now it's 14. Blue has leapt up to 30, blonde has leapt up to 37. And blue is still at 42. It was at 41, now it's at 42. So blonde might be the dark horse kind of making a break for it, and it might, we see things updating in real time. I love it. This is a very, very close race. Okay, fun stuff. Somebody said, what was about to be the secret word earlier? I was going to say the secret word is TF-IDF because that's, one of my favorite ideas in NLP. But accuracy is just it's an actual real word, and TF-IDF is an acronym. I do like flower crown being a secret word. Maybe next time. But okay. So I guess at the end of this session, we'll pop in and we'll see what's what. Although I do actually have, there's something I need to confess, but I'll say I've already picked up a couple different dyes from the store just in case. So as soon as this wraps up, I can start dyeing my hair. Okay, fun stuff. So we got the voting out. Also, of course, leave me questions or comments or any kind of feedback. I'm going to take a break and drink some coffee. And then I will play you my Birds Aren't Real song. And I will definitely play you out on some kalimba again. Okay. For this song, I have to take off the flower crown, put on my hat. This one I actually sing for you. I say I'm not like the most proud of my singing voice, but we make it work. We make it work. All right. Get ready to have some major truth bombs dropped at you. I'll zoom out a little bit so you can see the ukulele. I am so unsure about so many different things that I have heard, but there's one thing of which I am certain, that the US government invented birds. They are fake, you can see it in their eyes. They're the NSA's favorite little spies. But there's one thing of which I am certain, that the US government invented birds. Stay woke, sheeple. All right, that is my song about birds. I'm gonna put back on my flower crown, and we will get back at it. Possibly the best song that I've ever written. Okay. So if you're not familiar, there is this conspiracy theory online that in the 80s, all the birds died off and they were replaced by robots, by the government. And this is all the birds hang out on power lines because that's how they get charged, right, through their feet. Y'all are very, very sweet. Ooh, okay, actually, somebody mentioned I should play multiple instruments at a time. Back in high school, I had this talent show act that I did with one of my friends, where it was a mashup of Somewhere Over the Rainbow and I'm Yours, and I was playing the piano, the ukulele, and the cups at the same time, and she was playing violin and the cups at the same time. So I'd be I would do strumming it on the ukulele, and then like playing the piano, and then spinning around and playing the cups with spoons. It was a good time. I'll see if I can find that video and drop it for you. But yeah, I don't know. I don't know what multiple. I guess I could get out of like a kazoo. I could do ukulele and kazoo at the same time. That could be good. Y'all are all very sweet. And you see, this is why I wait until session 3, because y'all that are sticking with it, y'all deserve all of the fun stuff, you know? Okay. Oh, this is so fun. Okay, so blue has jumped up to 49 and blonde has jumped up to 45. So things are going nuts over here. This is actually like a little bit scary, just like knowing that I'm about to dye my hair and not knowing what color it's going to be. This is, you know, just know I'm giving you a lot of power, right? Oh, also, y'all, I just keep realizing that I need to get better at streaming, that I just left my head small that entire time. I should have jumped over here. Let's see. How many votes does Baby Pink have? Let's see. I will check. Okay. Yeah, and I'll actually run through all of them. Okay, so blue, as I said, 49. Blonde has 47. Red has 16. Silver has 6. Purple has 7. Orange has 4. Black has 4. Baby Pink has 4. And then things trail off after that. Oh, okay, so this is tricky, and this is why I added Baby Pink as an option, because Baby Pink capitalized has 4. Baby Pink not capitalized has 2 votes. So technically it has 6 votes. But y'all, if y'all like this, next time I do Global Hack Week, we can do this again where we can re-dye my hair, and you can, you know, you can campaign to get it a different color. Ooh, I like this idea. If they tie, we'll do half and half. No, I'm down with that if they tie. Let's see. Can you do top 2 colors? Like the winning color would be the main part and the second would be streaks. I kind of like that. Maybe I'll leave part of my hair the second place color. Yeah. Especially, I think this is actually easy because, you know, if I'm going to dye my hair blue, yeah, I have to start by bleaching it blonde and then adding the blue on top, right? Otherwise, it wouldn't look very good. So if it is blonde and blue, that'll be easy. I'll do it all blonde, and I'll make most of it blue. Blue and blonde would make you like neon. Yeah, it'd be it's going to be loud regardless of what happens. But yeah, okay, let's get back to some coding. Hopefully everybody took a break and got to pat themselves on the back. As always, you know, mad props to everybody who's sticking around. It means so much to me that y'all are interested in nerding out with me. So we have just updated our model where we are learning our weights from the data, right? And this is sort of the language that I encourage you to use, is that we are looking at the data and we are learning from it what our weights should be for different words, right? So we're learning for, where's our list? For these words, you know, great, highly delicious, our weight should be +1. And then for these other words, you know, horrible, return, change, stale, that our weight should be -1. And learning weights from data is really, really useful. But what we can do is, and this is where we get to like the joy and the massive power of machine learning, is that just by adding more data, we can actually get better at it. And this is actually something that I did not test before, but earlier we grabbed the first 1,000 rows. And what happens if we grab 2,000 rows? In fact, I'll copy this. And so instead of just 1,000 rows, we'll use 2,000 rows. And we won't change anything else except for we're just adding more data. So we'll run this again. We'll get our normalized values. Yeah, no, this is a really good point about dyeing, and I'm gonna try to get it as blonde as I can before I go blue. If it's blue, it might not be blue, it might be blonde, it might be baby pink, you know. But if it is blue, I'm going to try to get it as blonde as I can. I think there's a decent chance it might still come out kind of like a teal green kind of thing. And somebody asked if I'm doing this myself. There's a friend helping. I might have my neighbor come over and help me, but I might just be doing it myself. We'll see. Okay. So you can see we added some more data, and our words changed a little bit, right? So we can see some of the words are still there, like highly and love and great. But I think wonderful and recommend are new words, right? You can also see actually that our dash dash, it used to be at the very top, and now dash dash is lower. And this kind of gets back into what we were talking about. If you just add more data, a lot of these little problems can actually just go away, right? Because dash dash is in some of the top reviews, but it's not in all of them. Yeah, okay, somebody noted dog is in here, and I think that's super interesting. And I mean, there are a lot of different ways we could talk about this, but like, I don't know, I feel pretty positively about dogs, you know? Yeah, it's interesting to look at. So we have some different words. Another thing we can do is instead of just grabbing the top 10 words, we can grab the top 20 words of the negative and positive, right? And you can see some of those other words pop in. Again, some of these words don't really make sense. Like she being positive, like, that might be a blip, right? Maybe that goes away if we add more data. Or yeah, somebody called out like donut being a negative word. Like, I don't know. That's like an interesting question. Yeah, I'm not here actually. There's a great session that we could do on removing gender bias in natural language processing. It's not what we're doing today, but in a future Global Hack Week, I would love to do that. There's a lot of cool math you can do to get rid of gender bias. Somebody said you think there's dog food. Yeah, and if there are just a couple of positive dog food reviews, that could bias it, right? So now we can predict again, and now we're predicting on 2,000 records, right? So in some ways, we're actually giving ourselves an even harder task, but we have given our model more data, right? And so we're at 46, and I actually have no clue what's going to happen. I think somebody said they ran it and they got 35%, so maybe we actually don't do better, and we can talk about why. Oh, look at that! We jump up to 52%. So we gave our data, our model more data and more weights, and we ended up getting a better accuracy, right? And importantly, we actually just crossed over the threshold, and now we're getting more than half of them right, which I think is really, really cool. And I guess just to back up and to talk about what's really cool about this is we didn't have to manually improve our model at all. The only thing we did is if we scroll up, we changed this from 1,000 to 2,000. So we gave it more data, and then we changed these from the top 10 words to the top 20 words, right? And that's an important part. I think the folks who are getting 35% are not including that. Somebody asked, what if we train on the full data? And yeah, we're gonna get there. We're gonna continue to add more and more data and see how things improve. But we're gonna take a little bit of a left-hand turn and learn about something new. So far, we have been sort of manually mucking around and writing our own models, right? And you know what, this model right here, this is cool, but it's still kind of brittle, right? Basically what we have done, learning all of these weights, is really the core of an algorithm called logistic regression. And logistic regression is basically what we've just been doing, is you look at your data and you see, is this thing on average, is it more likely to correlate positively or negatively with some kind of outcome, right? And then you add up all of those weights, the positive and negative weights, and you just say, is it above or below some threshold? So that we really have been walking through. It's not exactly how they would implement it in a library, but we basically have implemented logistic regression by hand. Yes, yeah, we're getting into some fun ML stuff. And really, what we have just done already counts as machine learning. We've been doing AI this whole time, but this is now machine learning because we didn't have to change our code at all, and all we did was give it more data and it improved. And if you want to know like the kind of the big definition of how do you know if you're doing machine learning, and the answer is if you can give it more data and more compute resources and it does better, then in that case you are doing machine learning. But so as I mentioned earlier, we're writing all our code and it is a little bit brittle. And ultimately, we want to be able to use really powerful models that other people have already built for us. This is really, most machine learning engineers are doing a lot of the science around it, but they are using a lot of code that other people have written. We have already been using a lot of libraries that other people have written, like NLTK, right? Yesterday we used the NLTK library to tag the parts of speech of our words and to lemmatize them. And we're going to start using more libraries for more of our tasks. But one big catch here is that we are going to have to do what's called vectorizing our text. This is going to be a little bit of a detour. We're going to learn about vectorization, and then we're going to get back and we're going to get to pull a bunch of fun toys out of the toy box. So let's go back and let's do another sort of play corpus to explore this idea of vectorization. Let's do a little text box and just say, vectorization. And we'll talk a lot more about exactly what this is, but the headline here is when we're using really powerful models created by other people, they always take in numbers, right? And right now we've still been using strings, and so we need a way of going from strings to numbers. And that is really all vectorization is you have some kind of data like strings, and you want to turn it into numbers. And we're going to explore a way of doing that. Okay, this is actually cool. Somebody asked, how are libraries created for ML? Is it some peer review stuff or open source? And this is, I'll say, I'm not the most qualified person to talk about this, but the answer is it is a little bit all of the above. So you will see a lot of the big libraries. So we'll be using Scikit-Learn today, and tomorrow we'll be using Keras and TensorFlow. And so TensorFlow is actually made by and maintained by Google. And so you do actually have this cool process where scientists will write papers on, I discovered this new way of doing something. And then the people who maintain TensorFlow will read those papers and they'll actually implement those cool ideas back into TensorFlow. And so you kind of get this cycle where researchers will use TensorFlow to experiment with new things, and they'll publish papers. And then the people who maintain TensorFlow will take those new ideas and put them back in the TensorFlow library. So you heard this idea of standing on the shoulders of giants. We do a lot of that in machine learning, right? Somebody else figures out how to do something, we build it into a library, and then suddenly everybody can use it. But actually, to loop back around, in order to use it, we need to have all our data basically in the format of a bunch of numbers. So I'm going to come up with a sort of a play corpus. So we'll say, remember, a corpus is just a list of documents. And I'll say, you like dogs. You like cats. You love dogs. And you love cats. So that's our four corpus, our four document corpus. We've talked about this a little bit, but if you want to just get all of the words in your corpus or all the tokens, this is what we call a vocab. And so we will initialize a vocab. And often we use a set to initialize a vocab. We haven't talked about sets yet, but sets are this idea of it's kind of like a list, but you can't have duplicates. So in a list, you can add the same item multiple times. In a set, you can only add an item once. And if you try to add it again, it doesn't do anything. So if you just want to get basically just your unique words, sets can be really useful. And so we'll say for doc in corpus, and we can still use our same preprocess. We'll say preprocess with lemmatization, and we'll throw in our doc. So we'll get our tokens, and then we'll say vocab.update tokens. So this will add all of our individual tokens to our set. And then at the very end, we can turn our vocab into a list just so we can preserve order. We'll sort our list. And then we will print our sorted list out. Let's see. Somebody said sets are unordered. This is true. Sets are unordered. And so if we run this, great. This should not be crazy to anybody. All we're doing is just getting all the unique words in our corpus, right? So we have cat, we have dog, we have like, we have love, and we have the word you. So our most basic method for turning a bunch of words into numbers is to just give every word its own number, right? So we could use our indexes as our numbers. So we could say cat is just equal to 1, cat would be equal to 0, dog is equal to 1, like is equal to 2, love is equal to 3, and you is equal to 4. And so all we're doing is just translating our words into numbers. And so what we could do is we could create vectors just by doing this translation. So we'll make a dictionary called word to index, and we'll make that a dictionary. And we can say we'll say I, comma, word in enumerate vocab. And I don't know if we've talked about the enumerate function before, but this just lets you go through your list of vocab and it gives you the indices. So this will end up being 0 for cat, and 1 for dog, and 2 for like, and 3 for love, and so on and so forth. Let's see. Somebody mentioned Python makes this so easy. I don't want to imagine all this would look like in C and C++. Yeah, we talked about at the very beginning about how Python is great because you can move so fast in it, and you can do all these things in other languages, but it does just take more time. So I'm glad you are realizing like how fun this is. Also, I can scroll up if there's something. Oh yeah, it's just covering it. But you can also always pop over to the link itself. But no, thanks for the reminder. I am almost out of coffee, aerosol can. Yeah, I think I'm gonna knock it back right now. Alrighty. Also I'm gonna zoom back in because I zoomed out for the ukulele. Sweet. Somebody said, I missed the enumerate part. Can you briefly go over it again? Yeah, so all enumerate does is it gives us the indices when we're iterating through. So for cat, I will be equal to 0, and the word will be cat. And then I will be equal to 1, and the word will be dog. And then I will be equal to 2, and the word will be like, and so on and so forth. So it just gives us numbers to associate with our words. And so we can just add these to our word index. And so we can say word to index of word is equal to I, right? So this will just give us a dictionary. We say cat is 1, cat is 0, dog is 1, like is 2, and so on and so forth. And now what we can do is we can actually create a vector. So let's create a list of vectors. We'll make an empty list, and then we'll say for doc in corpus. And we can again do our pre-processing. Tokens is equal to preprocess. And now we'll create an empty vector. So we'll say our empty vector is a list of 0, and we'll just multiply it by the length of our vocab. So we'll get a list kind of like this, only everything will be a 0. And now we can go through the words in our token. So we'll say for token in tokens. And we can say our index is equal to whatever is inside our word to index. So again, if we're looking at the token cat, then we'll get the number 0. If we're looking at the word dog, we'll get the number 1, and so on and so forth. And then the final thing we'll do is inside our vector, we'll take whatever the place is of that word, and we'll add 1 to it. So we started at 0. But every time you see that word, you increment that 0 by 1, right? So if a word appears twice, then you'll have a 2 in that spot in the vector. And then the final thing we'll do is we'll append our current vector to our list of vectors. And this runs pretty quickly. And so if we now just print out vectors, I want us to kind of walk through here. In fact, actually, let's say print, we'll unpack our vectors and separate it with a new line so it looks a little bit cleaner. This is another Python sort of power feature, but all this is doing is instead of giving us a list, it's just unpacking every item in the list into our print function. Not super important, but a fun feature you can use. Oh, interesting. Okay, so we did something wrong. What did we do wrong? Let's look at our word to index. Maybe somebody already can spot the bug that I have. I'm using word instead of token. So we're iterating through tokens. Oh, and so we want to use that token. Aerosol can ask what this does. So if I remove this, it will just print it all as a single list. But if you do the star, it's what's called unpacking in Python. And so it basically says, instead of a list of all these things, pass all of the elements as their own individual individual arguments. So another way of writing this, instead of using the star, is we could say vectors 0, comma, vectors 1, comma, vectors 2, and so on. And so that looks pretty similar, but a sort of faster way of writing that, excuse me, is just unpacking them. It's kind of it's just kind of a fun power feature. So we run this again, we should get our correct vectors, and boom. Okay, now I want us to take a second and really look at this because this is pretty powerful. Let's see. I see there are a lot of loops here. I can imagine in real life situations and algorithms, I'm a lot more optimized, especially since we want to operate on large corpuses. Yeah, so this is an interesting question and a good thing to dive into. I don't want to get too nerdy on you, but we can really get into this. So let's pick numbers for the size of everything. Okay, so let's say our number of documents in our corpus is, let's say it's D. So D is the number of docs in our corpus, right? So if we have 100 docs in our corpus, D is 100, right? Then over here, let's say the maximum number of tokens in a document is T. So that is the maximum number of tokens in any document, right? And so I think it is a good intuition to develop that anytime you see nested loops, you should ask a question about the performance, right? But here is sort of the beauty part here, is that D is not directly related to T, right? You can have a lot of documents and they can all be small, or you can have a small document, or you can have big documents and only have a few of them, or you can have big documents and have a lot of them, right? And so if we look at our terms, well, okay, we're iterating through every doc in our corpus. So here our term is D, and then here we're iterating through all of our tokens in each document. And so the maximum value here will be T. And so if we actually look at the sort of the running time complexity of this algorithm right here, of this nested loop, it would be, for those of you playing along at home, it is O of D times T. Now, what is important here is that, okay, so somebody mentioned n squared, and it is not actually n squared, right? And this is actually really important because these things are different, right? And oftentimes when we make our corpus bigger, we will make D bigger, but T will actually stay relatively small. And why this is important is if we can think about T as a constant, if we can just say we're not going to have any documents bigger than 100 characters, or even a big number like 1,000 characters, then this suddenly becomes a constant, and we could say, T equals 100. And if you remember, if you've taken any sort of data structures and algorithms class, if you're looking at the running time complexity and you have a constant, so if instead of that T, we just write 100, you can actually drop it because it ends up being negligible. Yes, this is exactly right, is that T ends up becoming negligible, and so you can drop it. And so really, the running time complexity that we care about, yeah, Aerosol Can has it right, Arrow has it right, is really the running time complexity is just the number of documents. So I warned you, we get really nerdy here, and I hope most folks are still interested. But this is a really good question to ask, and this is kind of the answer, is you want to write your algorithm in a way in which you are only scaling up with respect to one thing. Let's see, somebody asked, there are D docs, each has T words, so total iterations are D times T, and this is kind of the first iteration we took where we said, yeah, the running time complexity is D times T. But if you can just say, well, our documents or our token size will not grow arbitrarily large, then you can say that's a constant, and then you can just drop it. So getting into some funky math, but I did promise people math, and I'm delivering. Good stuff. Yeah, okay, thank you for bearing with me on that little nerdy detour. But let's hop down. We just generated some vectors, and I really want to walk through this because this is a really, really important concept in really all of machine learning, is this idea of vectorization. So if you look at, I'll pull down our original corpus. I'll plop our corpus down here. So if you look at up here, our sort of vocab is cat, dog, like, love, and you. And if you look at our first sentence, it's you like dogs. And so if you go into this vector, okay, u is 0, 1, 2, 3, 4, right? And so if we go to the last place here, we have a 1 because u appears exactly once. Then we have the word like. And like is in our list, it's the third thing. So if we go to the third item, okay, we have a 1 there. That's good. And then finally, the last word we have is dogs, or dog. Oh yeah, I guess it gets lemmatized, doesn't it? So dog is the second item, or at index 1. And so if we go through, at our second item, or index 1, we have a 1. And all the other spots are 0 because cat and love don't appear in the sentence. So just to zoom out and reiterate, the only thing we're doing with vectorization is taking words and turning them into numbers, right? And there are a lot of different strategies for turning your words into numbers, but this is kind of the most basic one, is just doing what's called a count vector, where you're just counting up how many times does each thing appear. Now, something that you might be aware of is the fact that when we do this, we actually lose information about order. And this is something we're going to look at more really tomorrow, and we'll get more in the weeds on some models there. But I just want to take a moment and let this sort of seep in, because this is a really, really important concept that pops up again and again. So I know I just mentioned that this kind of gets rid of the order of things, and that is because we're using what's called a bag of words model. You hear this term bag of words, and it's really like you just throw all of your words from the document into a bag, and you don't really care about order. You just care that they're all in there, right? And that is a bag of words. Okay, so we've done vectorization. Pat yourself on the back. Vectorization is like a big concept. We also took a deep dive into running time complexity, which is so cool. I'm so glad we went there, because it is an interesting concept. As I can said, have heard while learning about seek to seek. Oh yeah, okay, we will. I really hope we get into, we will get into sequence models tomorrow. I hope we have enough time for it all, but we will touch on sequence models at very least. We might, I'm hoping we'll have time to actually do some text generation. We will at very least be ingesting a sequence, but yeah, hopefully we'll get to generate text. I digress. Onward, forward and onward and upward. Fun. So we've done vectorization. It's this big idea that's really important. But notably, we don't want to have to always do this ourselves. And this is where we're going to start using more libraries. Oh, you know what? I think about starting YouTube all the time, and I think it would be a lot of fun. Honestly, I just really enjoy Global Hack Week, and it's like a nice format where I don't have to manage things. But you know what? If you are having a good time, let me know, and maybe I'll be forced to start a YouTube channel at some point. I think it would be a lot of fun for what it's worth. I love hanging out with y'all. Okay, so we don't want to always be depending on writing our own code, and so we're going to use other libraries to do this work for us. And so one of the big libraries we're going to be using a lot is called Scikit-Learn. So we will import. We'll say from sklearn. Feature extraction .text, and we'll import count vectorizer. Now, the count vectorizer just does whatever the thing that we just did manually, right? It will just produce these vectors for us. Y'all made me feel so good. I enjoy all the positive feedback. It's great for me. And you know what? If you peer pressure me enough, yeah, maybe I'll just have to do it. Everybody's got a YouTube channel these days. Yeah, you know, I was thinking about doing a podcast back in the day, but it's just time, y'all. Okay, here's a question, just because we're already off topic. How often does somebody need to post to have it feel like they're really doing it? Because like I have YouTubers that I follow that basically post every week, and like that feels great, and I'm like, oh yeah, every week I'm gonna check in and see what they're up to. But every week is like a ton, right? I don't know. It's like if somebody's doing it every 2 weeks, does that feel like not enough? Well, let me know what you think. Somebody said bite-sized ML and TikTok. That actually could be fun. I need to get on TikTok more. Yeah, make it meaningful. I hear that. Good stuff. Okay, back to the content. But yeah, keep peer pressuring me, I guess. So count vectorizer does what we just did, but all by itself without us having to write that much code. So we can initialize it by saying vectorizer equals count vectorizer. And this is sort of the big step here, where we can say vectors equals vectorizer dot fit transform. Oh, not counter vectorizer. And fit transform, this is, I guess I'll take a little bit of a detour and say, in Scikit-Learn, we have this idea of fitting a model and then transforming new data. So fitting the model is basically doing what we did up here by building up our vocabulary, right? So right here, we're fitting our model and going and checking what are all the words out there, right? And then transforming is actually taking that data and turning it into vectors. So fit transform does both of those at the same time, and we get a list of vectors. And so then after we get our list of vectors, we can print vectors to array, which just gets it into a nice array format for us. And oh, vectorizer has no fit transform. What? Wait. Oh, transform. Fit transform. Boom. Okay. This is kind of the big reveal where we just say, yes, it does nothing different, right? You can look at this list of vectors, and it's exactly the same as the list of vectors that we came up, down to the exact number. So this is just a nice tool that we can use so we don't have to keep writing all of this code that we just wrote up here. So really nice count vectorizer. We'll use it in the future. Let's say post when you want to, just don't make post for the sake of it, make it meaningful. I hear that. That's like I'm not here trying to make bad content, you know. Twice a month, I can see a world where I do twice a month. Some folks post monthly. It lets you spend more time on one video. Yeah, I like that. The editing is a consumer. Yeah, you know. Okay, I will say I actually have gotten a little bit into videography. I technically do have a YouTube. But it's mostly for like family videos and stuff. But I could drop the link. I guess you could also just find it out there if you want. But yeah, the editing is a big trouble. Yeah, you know, no worries for the big digression. Let's see, you can run series of stuff as in make it a playlist about ML. You know, I actually really like that. Okay, there is this. Now we're getting really off topic, but are y'all familiar with PEPs? They are Python has this cool system of it's called Python Enhancement Proposal, and let's see, Python PEPs. Here we go. Index of Python enhancement proposals, and there are tons of them. But basically, every time somebody wants to improve Python, they say, "Hey, I have an idea of how to make Python better," right? And I'm trying to find like maybe just pop through a good one. Okay, literal types is kind of interesting. This is so it's proposing like a new thing that you could do, which is, you know, annotate a literal type. It's a little bit nerdy, but this is how Python changes and how it gets better. And I think it'd be very fun to just go through and make like individual videos on different PEP proposals. So you'll have, you know, like PEP 586 and be like, hey, let's dive into, you know, what's meaningful about this. That's a massive digression, but yeah, it would just be a big nerd rabbit hole, but it could be a lot of fun. Yeah, no, mad respect to folks that read PEPs. There was a really big bug that I was fixing in my code base at Google it was because of a very specific PEP that changed something very minor about the way that Python interacts with your operating system, and I felt very cool when I read that PEP. Yeah, PEP is kind of like an RFC for sure. But yeah, I don't know. I have a fun time hanging out with y'all. It's a good time. Okay, let's see. Count vectorizer. Right, we know how to use count vectorizer. We've got 20 minutes left on the clock, so we will try to speed run, but we might just pick up where we left off tomorrow on this, and we'll get as far as we get, you know. Okay, so we can use this count vectorizer, and the really cool thing is once we have a vector, we have so many models that we can use really easily. So I'm going to go back up and just make sure we have our data. Okay, we have our data in data frame. And we are going to just pop out a model called Logistic Regression. So I'm trying to think of ordering here. Okay, so we have our raw DF. which has, I want to say 2,000 columns or 2,000 rows in it. Oh, wait, no, we have, what is that? 568,000 rows. Let's cut that down to, let's take 10,000. This will give us the first 10,000 rows. And we'll say that's DF. But now we're going to do something called actually creating a testing set and a training set. This is one of those moments where I have to tell you, this entire time we have been doing it a little bit wrong, right? We've been building models and we've been testing the model on the data that we trained it with. And this is the best analogy that I've found to explain this concept. I think most of us are in school, and you probably have had this experience of being given a study guide from the teacher, right? And the teacher says, hey, there's going to be a test, and so I'm going to give you a study guide of 10 questions, right? And if I told you, hey, the test is going to be those exact same 10 questions, you wouldn't actually have to learn anything, right? All you would have to do is just memorize the answers from the study guide, right? And that's kind of what we've been doing, is we've been giving our model the study guide, but it really is the same thing as the test. So what you can do to get around this is, say we have, instead of 10 questions, 100 questions. And what you can do is you can say, we're going to take 90 of the 100 questions we have and use them as a study guide, and we'll give that to the student. But then we'll save 10 questions for the test that you don't get to see. And so that's what we're going to start doing with our model, is we're going to separate it into a training data set, which is like our study guide, and then we'll also break out a testing data set that is like our actual test. So we'll say training DF, and this will just say is equal to, we'll say the first 9,000 sort of records. And then we'll have a testing data set that we'll say is equal to our last 1,000 records. And so in this way, you can think of every single prediction as a question on a test, right? Or a question on a study guide. Yeah, okay. Y'all know what this is like. You've studied for things, and you get study guides sometimes. I'm glad that it's a metaphor that kind of works, right? So we can run this, and we'll get a training data set and a testing data set. So now we will whip out that count vectorizer again. So say vectorizer is equal to count vectorizer that we already imported. And we'll say our training vectors are equal to our vectorizer, and we'll run that fit transform function again on our training data set, just the text of it. And just to be clear about what this is doing, let's just look at our first vector. So we'll say first vector equals training vectors, and we'll say to array, and we'll grab that first element, and we'll just print our first vector here. And then we'll also actually print our first vector dot size. That'll show us how big it is. And boom. Okay. So you see we have a lot of zeros here because a lot of our words aren't there, right? But it's just a big list of numbers. And then also you can see this number 18,141. And this is really cool because this is actually the size of our vocabulary in our first 9,000 rows. Okay, we have some great questions. Okay, so somebody mentioned validating data. We will get into validation holdout sets and cross-validation hopefully today. If not, definitely tomorrow. Are we doing epics and stuff yet? When would that play in? Yes, we'll definitely get into epics tomorrow, and we'll do a deep dive into overfitting. Somebody said, TBH, this is the best explanation I've heard about training and testing. Oh, I'm so glad to hear this. We will get into overfitting and underfitting. Somebody says, is it usually always 10% test and 90%, or I think you mean 10% test and 90% train. 90-10 is like a pretty normal split. A lot of people use 80-20 as well. It's kind of all over the place, kind of your own discretion. And somebody said, what does the Python colon mean again? I've seen it when looking at some leak code solutions, but it still confuses me. Yes. Okay. I love this. We'll do a little detour just on the colon and slicing. Okay. So say we have a list. We'll call it my list. And we'll put in it A, B, C, D, and E. We have 5 things. The colon just allows you to do what's called slicing. So the normal thing would be just say, give me a single index, right? And that'll give you A. But you could say, give me everything up until the second index. If you run that, you get a slice, which gives you the first two items. You could also say, give me everything after the second index, and that would give you all of those things. So the colon just says kind of up until, or from that point moving forward in your list. And it's technically called a slice. There is the answer to what does the colon mean. Yeah, it pops up in a lot of algorithms. Let's see. Okay, so somebody asked why logistic regression, and this is actually a. I guess I'll back up and explain some of the process here. When we do these sessions, I think the most valuable thing is really walking through and trying to understand how things work, right? It is very easy to go online and find a tutorial of just like how to copy and paste a model and use it. And we will do some of that because that's powerful. But I do like to take the time to walk through and really explain things from a basic level. And so that's like everything we've done today has kind of been walking through how do we understand what's going on with logistic regression. Logistic regression is a really simple model, and it's one that we can actually kind of walk through the internals of. And so I think that's a really valuable thing. I'm always open to feedback, and if folks feel like, hey, you know what, I like the deep explanations, but really I just want to copy and paste some models, I'm open to that, and I'd be down to do more of that content in the future. But in the past, the things that people have really liked have been kind of diving in, looking at how to do something manually, and then seeing if we can do it sort of automatically. But I think it's a really good question because there are like really good, powerful models out there that we have not started using yet, and hopefully we'll get there. Oh yeah, somebody said if you did A to B, so like for example, you could in a slice do 1 to 4, and this would give you starting at index 1 and going up to index 4, but not including it. So yeah, you can do something to Y. Let's see. Oh yeah, okay. Aerosol Can is mentioning checkpoints. Yeah, we will get into checkpoints and specifically trying to save sort of the model with the minimum loss, or the model that you have at the end of the minimum loss round. We will look at that. Again, hopefully, sometimes I wish that we could do like 7 sessions of this, but yeah, there's a lot to cover. Okay, we've got like 10 minutes left, and so hopefully we will actually finish using logistic regression today, and actually throw that model in there. So we've gotten our training vectors, and we use that fit transform function again. Now, and we looked and we saw there are 18,000 words, which means our vector is 18,000 items long, right? Just the length of our vector is that long. Now we can also create our testing vectors. So we could say testing vector is equal to, and we'll use that same vectorizer. And this time we'll just say transform. And this is kind of an important nuance bit here. So we'll say testing df, and we'll include our text. But what we're saying is make a vector the exact same shape as our training set. Because something that becomes an issue is if you have a new word in your testing set that is never in your training set, your model won't know what to do with it. And so it's really important that you only create a vector in the same shape that you use to train it. So your training vectors should be the exact same shape as your testing vectors. I misspelled test df. So we'll run that, and then we'll do the same thing where we can do our first testing vector. 0 equals testing vectors. And we'll print that out. And importantly, we'll print out the size of it. And what we're looking for is it should be, oh, test df isn't real. Oh, is it testing df? Dadoy. And, oh, I think we forgot to do toArray. So let's say toArray, which turns it into a nice array for indexing. And great. Okay, this is the thing we wanted to check, is that it's the same length, which means we're only getting vectors of the same format for testing. Even though they're different data sets, we'll make them the same size. Somebody said my keystrokes are beating your heart. I hope that I'm not typing too loud, because I know I can type relatively aggressively. But yeah, that's a thing I hear a lot. But hopefully that's a positive thing. Okay, incredible. So now, in order to actually get to the point where we can train a model, we also have to grab our labels. So remember, our labels are the things that we're trying to predict. And in this case, that's how many stars it gets. So we'll say training labels, and we'll set that equal to our training DF of score. And we can say testing labels is equal to our testing DF of score. So this is just grabbing the scores of our training samples and our testing samples. And we can look at what training labels look like. We can just look at the first 10 of them. And so this is just saying the first sample gets 5 stars, the second sample gets 1 star, the third sample gets 4 stars, and so on and so forth. Okay, we've done a lot of prep work, and now we get to actually pull out the cool toys. I know I've been saying we're going to pull out the cool toys in a second, but now we're really going to do it, right? So we will import a logistic regression model. So we'll say from Scikit-Learn linear model, and we'll import logistic regression. Will you autocomplete for me? Boom, logistic regression. Incredible. And we will create a logistic regression classifier, and we'll set that equal to logistic regression. Boom. And now, this is the step where we actually do the training. And I want to try to tie this all together here at the very end, is we're going to say, so we'll say logistic regression classifier. We'll fit it on our data, and we'll pass it our training vectors and our training labels. And the important thing to realize here is in this single line of code, it is doing all of the stuff that we did up here, where we get the counts of different things and we see what weights should be assigned to different words. And it is doing all of that for us, right? This really, it's this line of code and this cell of code and this cell of code, and really this cell of code as well. It is doing all of that stuff in this single line of code. And that should feel pretty powerful, right? We went through all those steps to understand what was going on sort of underneath the hood. But it's really, really nice just to be able to import this one library and do it all sort of automatically. And boom, okay, we have trained our model just like that. And so now we can actually test it, and we can say logistic regression classifier, and we will get a score on our testing vectors. And see, this is now really important because we're testing it on something that we didn't train it on, right? So we'll have our testing vectors and our testing labels. And we will actually see how well does our model do on stuff that it has not already seen. And this tells us actually if it's going to generalize. And boom, would you look at that? 77. That is getting 77% of our records correct. Yeah, that is really awesome, right? To me, that's really impressive. That is basically the only things that changed here are that we use the very optimized library to do it, and we just gave it a lot more data, right? We gave it 10,000, or we gave it 9,000 samples. We gave it a really, really big study guide, right? And it went through all of it. Yeah, no, that's like, I mean, in my opinion, that's a really, really impressive score. Given, again, I'll remind you that if you were randomly guessing, you would get 20%. And in this case, we're getting 77%. So at this point, you should really, pat yourself on the back and say, we've made some real progress. I think we're going to call it there, and we'll pick up with artificial neural networks tomorrow. But thank you so much for tuning in and hanging out with me. I always have a good time. Thank you for gassing me up. I appreciate it. Let's see. Somebody said, can you recommend any decent sources to learn some more ML outside these sessions in our last few minutes? That is a great question. Oh gosh, the best. Okay, so this is going to be a little bit of a weird recommendation, but there is a Medium account called Towards Data Science that I have found really, really great tutorials from. Let me pull this up and make sure that this is the right thing. So if you want to just find sort of random tutorials on interesting things, sort of out there in the world in machine learning. Towards Data Science is a great read for a lot of these topics. I would say it's actually probably one of the best resources that I have come across. The other big one that I'll say is actually the Scikit-Learn documentation is really, really well written. So if you want to learn about different algorithms, they have a bunch of different resources where they walk through, how to use classification and all that stuff. So I'll drop that as well. Somebody asked how many words per minute I can type. I actually have no clue. I'm gonna guess not very many. I don't type like super fast, but somebody mentioned Andrew Ng, and yeah, there are a lot of Coursera courses that are really good. Coursera Intro to Machine Learning. I think there even was. Yeah, this is like a really common one that people throw out. I think that you can do this for free. You just have to pay if you want the certificate. So that's good. Oh, yeah, thank you for dropping my my Twitter. If there are a lot of y'all on Twitter, maybe I'll start tweeting more. But I have historically not tweeted that much. But yeah, we could get into it. Okay, so there are a few resources that I think are really good. I would say actually, everybody throw in your own favorite resources for learning about machine learning. But yeah, so that is our content for today. I will post this all. Oh, somebody asked this question about failed to converge. This is actually a thing you get quite a lot. There are a lot of different things to say here. Basically, one of the things this is saying is that we're training on a lot of data, and your model is going to kind of zoom in and be better on some data or some other data. And so you can get in these loops where, well, when you train your model on this part of the data, it does better on that. And then when you switch it over and you train your model on a different part of the data, it is better on that. And sometimes we like to actually achieve one model that kind of does equally well on everything. But you can get a case where you don't actually reach that point. Now, you can play around with giving it more iterations of training. Somebody mentioned this, and you can increase the max iterations. In many cases, unless you have a specific reason to believe that you are getting a sort of like having a specific problem with this, a lot of times I actually just ignore this message. But it's a thing that you can play around with and try. Let's see, somebody mentioned, somebody wants my YouTube channel link. Okay, y'all, this is, to be clear, this is me saying we're friends and I'm trusting y'all because this is not very curated content. Let me see. I mean, I guess it's not that bad because you probably could just find it anyway. Yeah. Oh wait, I don't even have one of my videos that I'm really proud of is not even public. Sorry, y'all get me on a big left-hand turn here. I made a little family video. Okay, I'll make it public. That I'm actually relatively proud of my skills on the editing of this one video. Okay, I will drop my YouTube channel. But again, it's not machine learning. It's not. I would not expect anybody to be particularly interested in it. Let's see. Okay, yeah, drop the YouTube channel link. Maybe we'll do more stuff there. I am so glad that you were enjoying your kind of intro to ML. Somebody said they got 92% accuracy. That actually is raising some question marks for me. I actually maybe after I finish this, I might actually review everything to make sure I am not doing something dumb and misleading people. Maybe I made some kind of error. It does depend on the random state. And there might have been something if you, for example, if you were either gave your model more or less data, or something that's very important is if you scored on your training data. Like I bet if you score on your training data, I bet you get a higher score. Okay, there you go. Yeah, if you score on your training data, then you get a very, very high score because that's like giving somebody the study guide and then having the test use the same questions, right? That's kind of our analogy there. But if you run on the testing set, then you should get a slightly worse score. Good stuff. Thank you for the feedback on the video. Yeah, that is one thing that I'm kind of proud of. But But yeah, thank you so much for tuning in. I will take a look at this to make sure I did not make any errors before I post it on GitHub, but I will post it on GitHub soon. And oh, before we leave, I'm going to do the final tally on what color I'm dyeing my hair. Let's see. Let's get back over to the feedback form. Oh, y'all, this is incredible. Okay, so blue now has 50 votes. And blonde tapped out at 45. So I think the thing that I'm going to say is I will contractually, I promise to dye my hair whatever color had the most votes, and that is blue. But somebody mentioned you could leave a little streak of the second place, and because that's blonde, I will leave a little bit of my hair blonde just for y'all. Yeah, no, thank you so much for being here. Somebody said, can we choose your hair color using sentiment analysis? And that would actually be very fun if like I weighted your vote based on how positive your session was. Yeah, no, thank you so much for showing up and being here. And thank you so much for helping one another. Like, I love these sessions because it does feel like we're all kind of in this together. And, you know, it's very sappy, but it's very sweet to see everybody helping one another. And that's, you know, that's really cool. So thank you so much for being here. Tomorrow, we will touch on, you know, we might actually jump straight ahead to Keras and TensorFlow and look at some more powerful models. And that could be a lot of fun. But I guess on that note, I will leave you to it, and I will go dye my hair because that's what I promised I would do. So thanks so much for being here. And before I take off, I guess I will just remind you that tomorrow at 4 p.m. Eastern time, which I guess is 1 p.m. for me, my time. That is when we will be doing part 4, and you can tune in and see my hair, and we'll do some more kalimba. And as promised, I will play you out on kalimba. We will call it a day. All right. Thank you so much for being here. It's great to see you all again. Take care, and I'm excited to see y'all. See you tomorrow. All right. Peace out, y'all.